All right, so I am Gareth, and I'm going to be talking. My presentation is Dr. SaltStack, or how I stopped worrying and learned to replace the cron. I'm a big fan of punny presentation topics. So when I thought of doing this presentation, I thought I have to somehow incorporate Dr. Strangelove into the talk. It just fit perfectly. So as I said, my name is Gareth Greenaway. I am the founder and organizer of the Southern California Linux Expo, also known as Scale. How many people went to Scale this year? Awesome. If you haven't been before, I highly suggest it, not just because I'm the organizer, but we have really nice weather in February in Southern California compared to the rest of the country. So I'm also an occasional co-host of Floss Weekly. Any Floss Weekly listeners here? Awesome. And I'm also a core contributor to the SaltStack project. If you haven't contributed code to the SaltStack project, how many people are contributors? Nice. I highly suggest it. It's one of the best communities to get started contributing to an open source project. Very friendly. If you've never contributed code to a project before, highly recommend it. And if anyone wants to follow my random ramblings on Twitter, there's my Twitter account. All right, so today we're going to be talking about scheduling jobs, specifically under Unix-like operating systems, so Linux, FreeBSD, OpenBSD, anything that's like a Unix-like operating system. A lot of the concepts will work on Windows, but I'm not going to focus too terribly on them. So the ideal situation of what we want when we're scheduling jobs. So we want to be able to easily schedule a job. We have a job in mind, something we want to run on a regular basis, repetitive task. We want to easily be able to add that to a schedule. We want to get notifications once a job is completed. Either the job was successful, the job failed, and any output that the job gave us. We want to have different notification scenarios depending on what the job is. So if you have a job and you want to send a report to someone, you want to be able to say, okay, this report goes to this person, whereas these jobs over here, they go to someone else. And we want to schedule jobs across many nodes. The whole concept of, I'm sure, is anyone here not familiar with the concept of pets versus cattle? Okay, good. So with that concept, we don't want to be logging into machines. We don't want to treat each machine as an individual snowflake. We want to be, a machine is a task, it's there to do a job. If it's not doing that job anymore, we want to migrate everything that node, that machine is doing to a different node to continue working. And finally, we want to be able to easily disable, enable, and move jobs between machines. So we have a few different options for scheduling jobs, just scheduling jobs in general. We're going to focus on two commonly found scheduling systems on Unix-like operating systems, AT and Cron, and we're also going to look at how SaltStack can accomplish the goals that we want. So AT is a Unix-like, on Unix-like systems, AT is a scheduling command. It runs them once and once only at a particular time in the future. When preparing for the talk, I actually tried to find some interesting information about AT, like who first wrote it, when it was written, when it first got introduced. It's very hard to Google something specifically looking for AT. So here's a typical example of running an AT command. In this case, we're echoing a command. In this case, we're compiling foo.c into foo. And we're going to run that at 11:45 on January 1st. Very simple. So the pros of running a job with AT. It's available on most Linux and BSD systems, even on Windows and OS X. It's a very simple syntax to schedule jobs, as we saw. It has management tools that are available. So AT for scheduling jobs, for ATQ for looking what's in the queue already, and ATRM for removing jobs that we don't want to run anymore. I didn't include it in the example, but you can actually get very simple notifications via email using AT. It is limited, though. So the cons. It's a one-time run. Like once you schedule an at job and it runs, that's it. It's not going to run again unless you specifically add it to the at queue again. And it's node specific, so we have to log into machines. Using just the at commands, we have to log into every machine and schedule the jobs manually. So going back to this scenario of what we want. So with at, we can easily schedule a job. We can get notifications on a limited basis of when that job completes. We cannot get different notifications based on the job because at, and please correct me if I'm wrong, because again, limited knowledge on, limited research available on at. Different notifications are not possible because when you schedule a command using at, it's going to send that notification back to you as the local user that is running it via email on the local system. So it is not possible to remotely schedule jobs across nodes using at, and we cannot enable, disable, or move jobs between them. So let's look at Cron. So I actually have some information on Cron. So Cron is the time-based job scheduler. It was originally written by Brian Kernigan. Modern implementations of Cron are ISC Cron, Vixie Cron, originally written by Paul Vixie. Also Cronny, forked by ISC Cron by Red Hat, and Anacron released in 2009. I actually wanted to include like a disappointed look of Paul Vixie in the slides, but I couldn't settle on one because there's so many of him looking like disappointed and grumpy. So here's a typical example of a very simple cron tab. So the first line, we have a mail to line, which is going to send the results of this cron job, all the output to the user at example.com. And it's a the next line, very simple cron line. It's going to run the command.sh from that lives in home user at 8 o'clock every day, every month, every year, etc. So here's a slightly more complicated example, a second command with a secondary mail to. So this is going to send the results of basically the command restarting Apache to the user admin at example.com. And it's going to run at 11:59 every day, every month, etc. So the pros of using Cron. It's available on most Linux and BSD systems, similar to at. As we saw, it's a relatively simple syntax. We have one management tool, cron tab, and we can get notifications. Again, limited by email. We can't tell it to use different notification methods. So the cons of cron, it's still node specific. And I don't know about you guys, but every time I need to add something to the cron tab, I have to look at the man page to remember what column does what. Anyone else? Oh, thank you. Okay, so going back to this scenario. So with cron, we can easily schedule a job. We can get notifications of the job by email. We can get notifications, different notifications depending on the job, by specifying different mail accounts. We cannot, strictly using the cron tab tools, or cron tools, we cannot remotely schedule across nodes, and we cannot enable, disable, and move jobs. I actually gave this talk at another event a couple of months ago, and when I popped up the last one, the enable, disable, and move job, someone raised their hand and said, well, actually, you can edit the cron tab and comment that out. And I said, yes, that is true, but it's kind of it's not the DevOps-y kind of way. All right, so alternatives. So we can manage our at jobs with Salt. So using the remote execution module at, we can add at jobs to nodes. So here's an example of running, using the remote execution job at to schedule a job on a node. So in blue, we have the selection criteria. So in this case, we're targeting a machine that is named, that Salt believes is named node 1. In yellow, we have the name of the execution module, so it's at. The function within that execution module, again, at. The time, 12:05 a.m. And the command that we want to run, reboot. And then the tag of reboot. The tag is just like an arbitrary kind of notification or an identifier to look back later and say, like, okay, this is a reboot job. So we can also schedule @jobs using states. So here's an example of scheduling an @job with a state. So again, if you guys are familiar with states, I assume. Yes. So rows is our unique identifier. Is the state module that we're using. Present is the function within the state. And the rest should look similar to the previous example. Job, in this case, is the command that we want to run. Time is when we want it to run. Tag is the, again, unique identifier. And then in this case, we're running that job as a user named Jam. So we can also manage cron using Salt. So there's similar execution and state modules for cron. So here's an example of setting a cron job with Salt. So again, we're setting the criteria of what machines we want to target. In this case, we're just targeting one named node1. The execution module is named cron. The function within that is setCron. Set job. We want this cron job to run as root or be in root's cron job. And then the rest is just the columns of when that job should run. And then the command finally in purple. And here's an example of a state that we're using to schedule a cron job. So the unique identifier at the top of what the command is and what's going to be in the cron job. The function, the state module that we're using, the function, the user, and then how often it should run. So it still has the same limitations that both and cron had when we were using the tools themselves. So we're going to look at simply using state, or using Salt as a job scheduler. So a quick disclaimer, some of the features presented currently are only available in development environments. I've noted what versions some of those features are, if they're either in the current release, the next release, or the development branch. So Salt has a very powerful scheduler. How many people are using the scheduler today? You should all be using it. It's awesome. So Salt allows the Salt scheduler allows incremental execution of modules or incremental executions on minions or masters. It exposes all the execution modules within the scheduler. We're going to be focusing on using the scheduler simply on minions. It is possible to use it on masters, but we're focusing on just the minions. So here's a typical example of scheduling a job within on a minion. So it's specific on the minion within the minion configuration. It's too big. So all scheduled jobs require a unique name. So they all live under the schedule heading. In this case, we have a job named job1. So that's the bit in blue. They all require a function, so what the job is going to do. In this case, it's running the state.sls function. We have in yellow how often the job is going to run. So in this case, it's 3,600 seconds or 1 hour. We're passing arguments, so these are non-keyword arguments. So in this case, we're passing the HTTP argument to the state.sls. So that will run a state file named HTTP. And we're passing a keyword argument called test. So test true. So we won't actually run it. It'll just test things. So we can also, one point on this. For the scheduler, if you're using like seconds and hours and minutes and all that stuff, it's based on the time of when the minion started. So if you start a minion at noon, like exactly at noon, and you have a scheduled job like this, the next time it will run will be at 1 o'clock, regardless of the time on the system, if you're using the seconds, minutes, hours, days arguments. So we can be more precise. So one of the recent additions in the 2014.7 release was to support cron-like time arguments. So in this case, we have the same function, the same schedule job, but in this case, it's going to run every 5 minutes. And the cron format works really well, but if you're like me, you still have to check the cron tab man page every time you want to schedule a job using this. Is there a question?
Can the scheduler handle like jobs independently? For example, job 2 has to be done or has to start after the job 1 is finished. Is that possible?
I mentioned that at the end. Yeah. Okay. So as I was saying, yeah, it would be nice if we could schedule jobs looking at this quickly and know exactly when this job's, because sometimes cron tabs can get really complicated, I find. So a little more clear, in the 2014.7 release, there's an argument that was added called when. So in this case, we're running the same job, the same scheduled job, a state.sls function with the HTTPD state file, but we're running it Monday at 8:15 p.m. And this is based on the local minion time of the system. So every Monday at 8:15, regardless of when the minion starts up, it will run. And we can specify multiple times of when it can run too. So in this case, same function. We're running it at Monday at 8:15 p.m. and again on Tuesday at 3 p.m.
Do you know if you can schedule it with a 24-hour clock?
That's a good question. I don't know. A lot of that code uses the Python date util library. So if you can specify, it basically it takes the time stamp that's in there. Sorry, the question was whether or not you could schedule a job using the 24-hour time. If you can specify, the date util parser basically takes the time, parses it, and turns it into seconds since the epoch. So if it can parse a 24-hour time, then yeah, it could be possible. It's a good question, though. Okay, so another example, just to give an example that you can run anything you want using state scheduled jobs. So here we're using the command.run module, remote execution module. We're running a job at Monday at 8:15 p.m. and we're just using logger to write a message of the load average into the logs, and we're passing some keyword arguments. So going back to the ideal scenario of what we want. So with Salt, we can easily schedule a job. We haven't looked at the rest of them, but we're going to. So notifications. Obviously, when you run a job, you want to get some notifications about what that job did, if it was successful, if it failed, why it failed. So in order to get notifications of scheduled jobs in Salt, we look at Salt returners. So the returner interface allows any data that Salt that knows about to go out to an external source. So here's an example of some returners that are in Salt currently. Again, the ones in blue are in the current release, the 2014.7. The ones in green are in the 2015.2, or will be in the 2015.2. And then the last one in red is in the development branch. So using the scheduler with returners. So here's an example of a scheduled job where we're using a returner. So we're running the status.procs remote execution module, and we're running it at 8:15 p.m. And all the data that gets returned from that is going to get sent to the XMPP returner. So now we'll look at how we can tell Salt where we want to send that data using XMPP. So returner configuration is all on the minion. Again, within the minion configuration file or within a file within minion.d. So here's an example of the XMPP returner configuration. So all of the returner configurations are prefaced with the name of the returner, in this case XMPP. And for the XMPP returner, we are using recipient. So in this case, account 2.jid.h. gmail.com, from or xmpp.jid. This is the account that's going to send the information from, and then the password. It's not an actual account, and it's not an actual password. Okay, so going back to this, we can easily schedule a job using Salt, and now we can get notifications of that job completion. And next we'll look at different notifications depending on the job. So available in the 2015.2 release, we can provide alternate returner configurations. So we look back at like the XMPP example, we could want to send different information to different accounts. So if someone was interested, hey, what's the load on the box at 8:15 on a Monday? They could configure a scheduled job to look at that, return it using the XMPP, but they want it to go to their account, not to everyone. So here's an example of using alternate configurations. So in this case, going back to the configuration of the returner, we're specifying an alternate configuration. So all the ones in green are just, it's an arbitrary name. It doesn't have to be alt. It can be anything you want. But they all preface the other returner configuration. So in this case, alt.xmpp recipient, alt.xmpp GID, and alt.xmpp password. So within the scheduled job configuration, we reference that alternate configuration by simply just passing the return config option. So then when the scheduled job runs and the returner returns the information, it will look at the configuration, looking for the information, the configuration that it needs first in that alternate location. And then once it doesn't find it, it will fall back to the regular configuration. So here's an example of that. So in this case, we have 3 alternate configurations for the recipients, but we have the standard configuration for the sender accounts. So going back to this, we can now get different notifications depending on the job that we're running by specifying alternate configurations for the returners. So now we're going to look at remotely scheduling across many nodes. So we can turn back to the remote execution remote execution system, rather. So in the 2014.7 release, there is a remote execution module called Schedule. And Schedule does just that. It allows us to interact with the schedule from a centralized location on targeting specific nodes. So in this example, we are targeting, in that first example, we're targeting a series of machines using grains. So within the grains on the minions, there's a role called web server. So we're targeting all those machines that have that grain. And we're running the remote execution module Schedule with the add function. And just as we saw in the minion config, we need a unique name for the scheduled job. So in this case, it's Apache restart. We pass the function in green, apache.signal, with the arguments restart, and we're telling it we want this to run every hour. The second example is using a slightly different targeting scheme. So in this case, we're targeting all the machines whose host names begin with cache. Same remote execution module, same function, different name. All the scheduled jobs need unique names. We're running all the machines, all the jobs need a unique name. In this case, we're running the function varnish.purge, and we're specifying the when argument and giving it 2 times. So when you specify the when argument for multiple times, you just specify it as a Python list. So we can also schedule jobs remotely using the state system. So here's an example of a state file, very similar to the last example where we had the remote execution module. So we have our unique name, Apache restart in blue, our state module, schedule, within the function present, and then the function that we want to run on the in the scheduled job, and then the arguments restart and seconds 3600. And again, this is based on when the minion starts up, so not based on local system time. And we can get this a little more complicated. So in this example, we're doing a state run with the HTTP file, and we want this to run Monday at 5 p.m., Tuesday at 3 p.m., and again on Wednesday at 5 p.m. So back to our ideal situation, we can now schedule jobs remotely across many nodes. Next, we'll look at enable, disabling, and moving jobs. Okay, so again, we turn back to the remote execution module for schedule. So in 2014.7, there's a function called disable job, and it does just that. It basically sets a hidden variable within the schedule job that tells the salt scheduler not to run the next time it iterates over. If you remove it, the next time it's scheduled to run, it will run. So it basically just within the code just says like, hey, is this bit set? It is. Okay, I'm continuing on. And here's an example of disabling a job on a minion. So again, we're targeting minions with the role of web server. We're running the schedule execution module with the disable job function, and we're passing it the job name Apache restart. So within 2014.7, there's also an enable job. Obviously, if we disable a job, we're going to want to be able to enable it again later. So same example, but in this time, instead of disabling the job, we're enabling it. So in 2015.2, there's a move job function. And this just does exactly what it sounds like. It moves a job between nodes. One of the caveats with this function is it uses the publish system. So the publish system allows you to run a command on another minion from a minion. So in order to use this function within the schedule module, you need to enable the ability for the target minion to accept publish commands from everyone or just the node that you're publishing from. I'm coming to that.
So I got a quick question.
Yeah.
If my memory serves me correct, you have to do that in the minion config, right?
The publish is in the minion config, yes.
Okay, and just, that's it. Let me think a little bit.
Sure. If someone has a better idea of how to do this without using the publish system, I would be more than welcome to hear it. I racked my brain for like 2 days trying to figure out how to do it, and publish was the only way I could come up with. Okay, so here are the other available functions that we have within the schedule module. The ones in green are in the 2014.7, and the one in red will be in the 2015.2 release. So copy is very similar to move. It also uses the publish system. It copies one job from another. Delete deletes a job. So that only deletes it from memory or from the running schedule. If it's configured in the configuration file, the next time you either restart the minion or reload, it will pop back into the schedule. We looked at disable. We looked at enable. List will list all the currently configured jobs on a minion. Modify, if you have a currently scheduled job configured on a minion, it will modify it. So if you want to change the function, change the time, change the returner, the modify is the way to go. Purge will purge all of the jobs that are running or configured to run. Again, it won't touch the configuration file, just the ones that are kind of running in memory. Reload will reload from the configuration. Right now it reloads from a file under minion.d called schedule.conf. Save will also save jobs to that. that file, and then run job will run a specific job right away without requiring the next iteration.
Quick question on that.
Sure.
If you delete the job, you said it's not going to delete the config, it's just going to delete it from memory. When you list, does it list what's in the memory?
It lists what's in memory, yes.
But not the configuration?
Right.
Can you repeat that question?
Yeah, so he asked if you delete a job and then you list the job if it's listing the jobs from memory, not the configuration. Okay, so going back to the ideal situation, we can now enable, disable, and move jobs between minions. So this picture has nothing to do with my presentation whatsoever. I like that picture. It's just a happy turtle. When I gave this presentation before, someone pointed out that probably the turtle is not happy, but I think he's happy. All right, so what can we run with the salt schedule? Like I said, the salt schedule, salt exposes all of the remote execution modules and all of the state modules to the scheduler that we're able to execute. So Salt roughly has close to 300 modules right now with roughly 3,000 module functions. Granted, not all of those functions and not all those modules are available on every system, but still, that's a lot of modules and a lot of functions that you can use for scheduling. So some other interesting features of the scheduler. So Splay. Splay was introduced in 2014.7. Who here had started off early with using Puppet? So you know what Splay does and why it's important? No? Okay. So early on with Puppet, and this is the last mention of Puppet I'll give at that SOC conference. Early on with Puppet, if you had too many minions connecting to a master at any one time, the master would basically die. And so they introduced a feature called Splay. And what Splay would do is basically, okay, you have your clients, your Puppet clients, set to run at a specific time. The Splay would kind of offset them by a certain amount of time. And so that your master would not be hammered by connections and requests. So Splay allows us to do something similar in Salt. So here's an example of a scheduled job using Splay. So in this case, we're running a Salt state run, and we're splaying the time every 15. Sorry, we're splaying the time a random amount of time between 0 and 15 seconds. And we can also specify the range of time that we want to splay. So in this case, same job, but we're splaying across a random amount of time between 10 and 15 seconds.
Does that mean it's not going to start before 10 seconds from there?
So the first run, the splay function right now is, the splay option right now is only supported if you're using like the seconds or minutes or hours arguments. The first run will run that amount of time after the minion starts up. And then the next time it runs, as part of that run, it adds that splay amount on. So it figures out, okay, somewhere between 10 and 15, let's say 12, I'm going to add 12 seconds to the next run. So the next run will be 3,600 seconds plus 12. And I forget your question. Can you remind me of your question?
I was asking if the start time means it's actually not going to run now. It's going to run starting between 10 and 15. It's actually going to push it. You answered my question.
Right, but I want to repeat it for the recording, or else the guy's going to get mad at me.
I actually forgot my question,
Okay.
but you answered it. Thank you.
I don't know the use case that this would solve. I'll let you more curiosity. Can start be a negative number?
So the question was whether or not the start time of splay could be a negative number.
So you're plus or minus instead of just plus.
I'd never considered that. I don't know. I've never tried it. I might have to try it afterwards just to see what happens. Just curiosity. Anything else? No? Good. Okay. So we can also do range. So range was introduced in 2014.7. So what range allows us to do, So we can specify a time when the job will run, a time range of when that job should run. So in this case, we have our state run, and we're going to have it run every hour, 3,600 seconds. But we only want it to run between the hours of 8 a.m. and 5 p.m. And this allows us to do, this option also works with the other arguments. So like if you're using when or using cron or using any of those other arguments. It's not just the seconds. And we can also invert that range. So this was also added in 2014.7. So if we want to have this job, the previous example was running between 8 and 5. If we want to have it not run between the hours of 8 and 5, we can say invert true, and then the hours outside of that range is when the job will run. Okay, so then return job. Yeah, go ahead.
Could you say don't run on Saturdays and Sundays and stuff? Like you run every hour, every day, except Saturday.
Not at the moment, but that's a good idea. So the question was whether or not you can specify a day not to run it or a time not to run it. Yeah.
You'd use the cron string.
Yeah.
Could you go back one slide?
Yes.
So that invert, is that meant so that you don't go, could you have also said between, instead of take away your invert, and you would have set your start time 5 p.m. in 8 a.m.? Is that why you have it? Is that why the invert's there, so you can't do that?
It could be. So the question was whether or not the invert was there because you can't specify a range, like a negative range. I would have to look at the code and remember what I did. Yeah.
How does the scheduler handle daylight savings time?
Damn it. I knew someone was going to add there. So the question is, how does the schedule handle daylight savings time? I knew someone was going to ask that question or was going to mention something about UTC. So. Depending on what you're using, if you're using like the seconds or minutes or hours, I think it would, the daylight savings would, because the time is going to change. I think in that example, it would run when you didn't expect it. If you're actually specifying the time using the when argument, I think it would run when you expect it to. Does that answer your question?
Sort of. In other words, you have to watch out for it.
Yeah. Yeah. Okay. So early on in the current release on 24.7, if you're running a scheduled job, it doesn't return any information to the master. If you're running like a regular execution module, you can get information back of what that job did, like all its arguments and everything. So one of the features that was added to 2015.2 was the ability to return that information to the master using the return job. So specifying return job equals true, we get information about that scheduled job back to the master. So then on the master, you can use things like the jobs runner, and you can list, do a list, and you'll see those scheduled jobs in the runner. So metadata. Metadata was another feature added in 2015.2. So what metadata allows us to do is add just an arbitrary dictionary of key values that we can use later to search for jobs in the job runner. So here's an example of a scheduled job with the return job equals true and specifying some metadata. So in this case, foo equals bar. So then when we go back on the jobs runner, we can actually search for metadata and say, hey, show me all the ones where foo equals bar, and it will return just those jobs. I know it's like my presentation was right before lunch, and I was like consciously trying not to run over. So if I go fast from this point on, I apologize. So until is an option that was added recently in develop. So what until allows us to do is specify, like schedule a job and specify a job, okay, I want you to run until this date. So here's an example of the state run, but we don't want this job to run past December 31st, 2015, 11:59. So some other reasons to why you want to use Salt as a scheduler, if you're not already convinced. So here's a typical cron job. So in this case, we have two jobs, one running at 8 o'clock and another running at, that's not a valid time, is it? That's hilarious. So just ignore that, pretend that's a valid time. So I'm ashamed to admit, but I've seen examples so many times of where someone will specify something like this, counting on the fact that job 1 will finish before job 2 needs to run. And job 2 relies on the whatever job 1 has done. It's a bad idea, don't do it. So a better way to accomplish this. So we could combine the commands. We'd have one cron job, one cron line, where we specify ampersand to ampersand, so that if the return code of command.sh is true, then command 2 runs. But if you want to disable one of those jobs, it gets messy. And again, it's not, we're treating the machine as like a pet, not a cattle. So we could have a third script that runs both jobs. Again, messy. Or we could just run the commands from a salt state. So within Salt and within the scheduler, we have the ability to use all the dependencies and the requisites. So it's all the requisites and dependency arguments that we can use. So we can specify a state file, and we want that to run at 8 p.m. And the argument is runjobs.sls. And within that state file, we can specify both jobs. So command.run, home user command.1.sh. Job 2 is command.2.sh, and it requires that requires that job 1 has already run. So it won't run until this one runs. So that has been scheduling jobs with SaltStack. Thank you. Any quick questions?
Does the scheduler live entirely within the salt minion process, or does it shell out to any system schedulers?
So the question was whether or not the scheduler lives entirely in the minion process, or does it shell out to external schedulers? And the answer is it's entirely in the minion process. Yeah.
So when a job executes, does it kick off a separate thread of execution?
Or is it blocking the minion?
That's a good question. I don't know.
Yeah, that's the problem. I don't know if I can trust the scheduler. I know Cron is doing its thing.
Yeah.
I know what to expect, but I have to know if something could, trip up the minion.
I know I've seen examples where it depends on what you're running. So if you're running like a high state within a schedule, and something like comes along and tries to run another high state, it won't let you because it's already running. But if you have multiple, if you had multiple calls to like command run with like different things, both at the same time, it will successfully run them at the same time.
You could also pretty easily get a dashboard with a return code and just eyeball the output to somewhere and then get visibility.
I actually heard this in a talk earlier. The scheduler is not blocking.
Okay, makes sense. Yeah.
Earlier you said that, is the scheduler blocking, yes or no?
Oh yeah. Does the scheduler block, or does it shell out to or create other threads?
Earlier, when we were looking at all the different commands to list.
Yeah.
You said it would list what jobs are in memory versus the config file.
Yes.
Can you elaborate a little bit on that? Are we talking about the config file on the master versus the jobs on the menu?
So the question was, if using the list function, it lists the jobs in memory, not the configuration file, and to elaborate on that. So if you were to add a job using the schedule module, and you didn't save it, it wasn't in the minion config, and you listed the jobs, you would see that job listed. If you had configured a bunch of jobs in the minion, and the minion starts up, it would load all those jobs into memory, and they would run. And if you did a list, you would see all those jobs as well. But if you add a new job, you would also see that one. It wouldn't be in the config file.
Because
You haven't saved it, right? And if you delete one, you won't see it in the list. It will still be in the configuration file.
How do you delete it from the config file?
You can either save, run a schedule.save, and that will take all the ones that are currently in memory and basically overwrite what's in the config file. Or if you're managing your minion configs using config management, that would be the way. Question over here.
So, regarding the notifications, is it possible to have different sorts of notification depending on the result of the job?
So the question was whether or not you can have different types of notifications depending on the result of the job. Currently, no. But that's a good idea. Yeah.
So let's say that you wanted to like remove a set of 3 servers and you only want one of them down at a time. Can you make them like the scheduled job on the second minion like dependent on a return from the first?
So the question was whether or not you could make a
It's an orchestrated using your own tool.
yeah.
That's a good answer. I was just curious
Yeah.
if it's possible to do something like that.
You could use the batch command to specify like numbers. That might be something that's like useful.
Anything else? Yeah.
Is there a way to change the time zone on the scheduler?
Is there a way to change the time zone in the scheduler? So one of the things that I started looking at after someone mentioned to me about time zones and everything was whether or not the date util library supports time zones, and it does. So you can actually specify a time zone within a date string and have it forced to a specific time zone. I don't know if that answers your question.
And in that case, does it actually pull the time zone from an external source, or does it just go based on your system clock right now, plus or minus the difference from GMT? So if your clock basically is off.
Don't know. I've only looked at it briefly. Yeah. All right. So I think we're out of time. If anyone has any more questions, I'll be in the hall and I'll be around later.